Hello everyone, my topic is applications of fog. In this topic, I am going to explain where the fog computing applications have been implemented in the real life. Let's get started. Before starting that, let me explain what is fog computing. Fog computing is decentralized computing infrastructure in which data, compute storage and applications are located somewhere between the data source and to the cloud. It is a computing infrastructure in which the data, storage and applications are located in between some cloud or in data storage. Fog computing allows computing, decision making and action taking to happen via IoT devices and only pushes relevant data to the cloud. It allows computing, decision making and action taking process to happen via the IoT devices and only allows relevant and important data to the cloud. This is known as fog computing. There are few applications in fog computing. I am going to explain only about these four: smart building, smart grid technology, smart traffic lights, visual security. So the first one is smart building. Fog computing permits free local operations for the optimized control functions. Not only a single floor but also individual rooms can have its own fog node, allowing emergency monitoring and response functions, climate control, lightning control, and supplementing the limited capacity of the computers and smart devices. In smart building, a sensor of cloud computing has been inserted in which every floor, not only every floor, every single room has been initiated with emergency monitoring such as climate control, lightning control, and other such things, in which if something happens, the sensor gets alarmed to everyone and makes them alert. Commercial buildings are equipped with several sensors to inspect various building operations such as parking space occupancy, temperature, and key card reader. And not only that, the sensors have also been placed in the parking space area and to check the temperature and also the key card readers. We don't need to go and check whether there is some space or how is the temperature. We can get to know through the sensors. Data from these sensors must be watched to find what actions are required, like triggering a fire alarm if smoke is required, as well as in the building when the fire sensors are placed. It alerts us when a little bit of smoke happens. So these are some of the simple cloud computing application which is done in smart buildings. This is the architecture in which there is an automated building in which there is some sensors have been attached in the building. It is based on the cloud service in which IoT and AI have been implemented along with edge computing and smart services. In the picture, it has been shown that the weather, the climate, if any smoke is required, the electricity, any damages is required, everything is controlled in the sensor and alerts us in our devices. The second one is smart grid technology. The smart grid can be defined as a smart electrical network that combines electrical network and smart digital communication technology. A smart grid is nothing but a smart electrical network which is a combination of electrical network and smart digital communication. A smart grid has capable of providing electrical power from multiple and widely distributed sources. It has the capacity to provide electric power from not only one but many and widely distributed sources, like from wind turbines, solar power system, and perhaps even plug-in hybrid electric vehicles. The electricity has been provided from not only one but many, multiple and widely sources, something as wind turbines, solar power systems, and hybrid electric vehicles. Through this, a smart grid network has been implemented. These are some of the components in smart grid technology. To achieve a modernized smart grid, a wide range of technology should be developed and must be implemented. To do this electric work, not only simple things but a wide range of technology should be developed and implemented. These technologies generally grouped into the in key technology areas. These things are not meant for small areas. These are meant for the large area in which the work is being done for large things. For that thing only, the smart grid network has been implemented for electricity. And the third one is smart traffic light. Smart traffic light SLT system interacts with several sensors of fog for monitoring instances for accident deterrence, preservation of a steady traffic flow, collection of relevant data for analysis, and improvement of the SLT network. SLT systems. The smart traffic lights helps to know where the accident has been taken place, where the traffic has been taking place, if any obstacle has been done in the road, or any of that happens. The sensor immediately points to the user where the error has been taken place. That analyzed information can be used in the prevention of possible accident occurred through warning signals with connected vehicles. When the sensor is connected to a vehicle and also to a traffic light, when something happens, it gives alarm to possibly few people who are beside of them. It warns by signing that there's something happened, like accident or any traffic. For sensing and monitoring with video surveillance camera, the sensors can be also used for video cameras, which can be recorded and can be seen what the exact problem has been taking place. The existence of an ambulance through its alert, alarm, and emergency light to systematically change traffic lights to permit pass through the traffic for emergency vehicles. It is also available for the emergency vehicles, where the light would be changed by the sensor, so that the emergency vehicle can pass through easily. This is done by sensor by changing the light. They have three major goals for smart traffic lights: steady traffic flow management, prevention from accident, analysis at received data to analyze and improve the SLT system. By implementing the sensor in the smart traffic, we can be easy. It will be easy for us in the traffic flow management. There won't be any traffic by applying the sensor, because before committing a mistake, the sensor automatically alerts the user. Prevention from accident. When if a car is going and another car is on its way, it alerts the driver that one car is on the opposite side. It alerts the driver, and the driver can be prevented from the accident. Analysis that receive data to analyze and improve the SLT system. Not only that, these data have been analyzed and stored, in which they can analyze and improve the smart traffic light systems. Accident requires a real-time response, while data retrieval and traffic flow control can be referred to lesser priority for real-time set of process. By implementing this smart traffic light process, we can get escape from the traffics, from the accidents in our real life. In this scenario, WLP and smart traffic light units can be deployed alongside the road for prevention, real-time transmitting data received services such as vehicle to vehicle, vehicle to fog nodes, and fog nodes to fog nodes. By implementing this smart traffic light, we can get a real-time transmission data such as vehicle to vehicle and vehicle to fog and fog node to fog node. And the fourth one is visual security. Video cameras are used in public places, parking lots, and residential areas to enhance safety and security. Nowadays, everywhere the video camera has been placed for security and safety. That is nothing done with cloud computing. This is also an application of cloud computing. The bandwidth of the visual data collected over a large-scale network makes it impossible to carry the data to the cloud and collect real-time data. Without a bandwidth, it was impossible to collect a large amount of data, because when a camera is placed in a public road, the whole day has been recorded, and it is a large data. Every data has been maintained with the help of bandwidth. For instance, a busy shopping mall with thousands of people moving around simultaneously, real-time monitoring and discovering of irregularities carry strict low latency requirements on surveillance system. Instead of keeping a watchman in the shopping mall, it is impossible for a single person to record every single person's doing. So it is easy to place a sensor camera which records everywhere every person, not leaving a single place. This is one of the simple procedure of application of fog. However, fog computing helps in real life latency sensitive distributed surveillance system that upholds privacy. Not only that, the fog computing has a total assurance of privacy, in which all our data have been stored privately only for the usage of when something goes wrong. With the help of fog architecture, video processing is logically divided between fog nodes located with the cloud and cameras. By doing the fog architecture, it is easy for us to divide the fog nodes and the cloud within the cameras. It helps in real-time tracking, anomaly detecting, and collection of results from data capture over time. By implementing the sensor in the cameras anywhere, it is easy for us to track where the mistake has been taken place and collect the data and capture it then and then. So these are some of the multiple choice questions related to applications of fog. Fog computing is utilized to dash all debris into a single platform. Option is integrate, option B is store, option C is task, and option D is flexible. So the answer is A, integrate. Fog computing is utilized to integrate all debris into a single platform, and the explanation is some tasks require large amount of computation and storage. Example, real-time video analysis are feasibly due to the limited capacity of hardware. To solve these problems, fog computing is utilized to integrate all debris into a single platform. So the second question is, challenges can be addressed within a single IoT network by what? Option is fog node, B cloud node, C data, D control. So the option is A, fog node, and the explanation is large cities faces challenges from traffic congestion, public safety, high energy use. These challenges can be addressed within a single IoT network by installing a network of fog node. As I said earlier, by giving one watchman, instead we can keep a camera which analyze every single movement of a vehicle or person or a place. So it is called as fog node. The third one is a lack of broadband dash and connectivity is a major issue in establishing smart cities, and the option is storage, bandwidth, address, city service, and the answer is B, bandwidth. And the explanation is a lack of broadband bandwidth and connectivity is a major issue in establishing smart cities, while most of the modern cities have one or more circular networks providing adequate coverages. So it is little difficult to implement broadband bandwidth, so that many cities have been implementing cellular network providing coverages. The fourth question is, building automation demonstrates the need for what? Option is edge computing, sensors, control functions, local operations, and the answer is edge computing. Explanation, building automation demonstrates the need of edge computing, intelligence, and localized processing. And the fifth question is, a commercial building may contain mainly dash component, memory, fog node, cloud node, sensors, and the answer is sensor. A commercial building may contain thousands of sensors to measure various building operation parameters, temperatures, keypad readers, and parking space occupancy. As I have explained you earlier, in the smart buildings, where the sensors have been kept and what are the uses of the sensor, what will it track, and wherever it can track. So that's all. Thank you.